question we get asked a lot is, how can I generate heating from air, ground or water, especially when it's cold outside? There's a lot of energy available right up until you get to absolute zero, which is minus 273 degrees Celsius. That's really cold, so even at minus 5 degrees, which we sometimes see in the UK winters, there's still a lot of energy available which we can use in heat pumps. So how do we make use of that available energy? The heat pump uses refrigerant which boils at a very low temperature, and it's important to remember that generally energy or heat moves from hot to cold, and as long as the refrigerant gas is colder than the source, which is your air or your water, you will be able to extract and move the energy from the hot source, which is the air, to the cold source. And that sounds odd because air at minus 5 doesn't sound hot, but in terms of refrigerant temperatures, that is hot. And again, remember that there's energy available right down to minus 273 degrees. So what's the difference between air, ground and water source heat pumps? Air source heat pumps, they're very prevalent in the UK and most people are aware of them. They're quite popular in domestic houses in particular, and they use the energy from the air. Now, the important thing around that is that the air temperature in the UK particularly changes throughout the year. So in winter we've got very cold temperatures, and in the summer we've got warm temperatures, hopefully. That means that when the heat pump is delivering the most energy, that will be in the winter time, and that's when you need most heat but it's coldest outside, and then your efficiency, which we're going to look at another time, is affected. So they're cheaper to install, but they utilise an energy source which is very variable throughout the year, and just when you need that biggest amount of heat is when it's going to be coldest outside. The ground source heat pump takes energy that's stored within the ground, and that might be through a vertical borehole system, which is where you're drilling down between 100, 200 or even 300 metres and extracting energy out of the borehole. Or it could be a horizontal system where the pipes are buried about 1.5 metres below ground level and they are spread out in a much bigger area. Just on the cost side of things, a horizontal array is slightly cheaper than a borehole array, but you need an awful lot of land, whereas a borehole system takes up a lot less space but is more expensive because you need a drill rig and you will be drilling down. But both systems work well, and they both work on the same principle of circulating a thermal fluid through the ground which absorbs the heat that's stored intrinsically within the ground and uses that within the heat pump. These type of systems tend to be a lot more efficient than air source, and that's because the temperature in the ground is a lot more stable all year round, especially as you go down deeper into the ground in the vertical systems. So you can expect a higher efficiency, but a more capital cost from a ground source heat pump. A water source heat pump is very similar to a ground source heat pump, but rather than tapping into the ground, you're actually tapping into a water source. So that might be a lake, it might be a river, the sea, a canal, any body of water that's big enough to hold enough energy that's required for your heat pump and for your building. The water within that waterway doesn't actually go directly into your heat pump, it will go into a heat exchanger where it will exchange the energy held within the water into a loop that then goes into the heat pump. Again, these tend to be more efficient than air source systems and can be cheaper than ground source because you're not having to drill into the ground. You are accessing a water body that's already there. There are other things to think about, such as environmental permits, but if you do have a water body near to the building that you want to heat or cool, that's certainly a path that you should look at going down. Just to recap, there's always energy available in air, ground and water right down to absolute zero. A heat pump works by taking these low grades of heat and increasing them to a level that can be used in your building. It's as simple as that.